launch only, the launchy they call that one. In Telugu it is. A launch plies between 2 points A and B on the opposite banks of a river, always following the line AB. There is a path with respect to ground. There is a one bank, there is other bank, there is a path with respect to ground. The distance S between the points A and B is 1200 meter. The velocity of the river current is 1.9 meter per second. It's constant over the entire width of river. The line AB makes an angle alpha 60 degrees. This angle, this path, how much of angle it will make with river current, this we know. With the direction of current. With what velocity u and at what angle beta to the line AB should the launch move to cover the distance AB and back in a time 5 minutes. You should go like this and you should return. The angle beta remains same during the passage from A to B and from B to A. Why we are giving this path? So here let me get into the thing. Path with respect to ground. We are giving definite path here. Why we are giving path all of a sudden? I think if you see boat will be very small, will not be that heavy. Launch means yes, definitely what happen, it will get into 6, 7, 8 meters into the water. The depth of water, river also matters a lot. So what they do identify, so where there is a path where the depth is around more than 5 meters, then on the launch can move. No? If the depth of water is only 1-2 meters, the launch cannot move. The launch cannot ply. So they identify the path. Okay, along that path only both return onward and return journey has to be made. Sir, what is there? It can come. Somewhere the launch may get stuck. Mud will be there or stones will be there. Not possible. So they'll identify a path. If you see the Kerala or some Tamil Nadu nearby Kaveri bank or in the Karnataka Kaveri, so many rivers are there, no? They go for a specific path here. I think there's a very practical thing. Let's work out. What is that U given? Carefully analyze and think and answer. There's a velocity of boat with respect to water it is. V is what? Velocity of river. For your convenience, I'll bring the symbols which you are familiar. U is velocity of boat with respect to river. Then how the velocity of boat with respect to ground should be along AB. I think this we will. The first onward journey. There's a question. Let's go for onward journey A to B. Path. For path AB, we'll discuss this one. Then how the velocity of boat with respect to ground should be directed along path AB. So for that, already VR is there. So VR, V will come here. So velocity with the velocity of boat I'll write. I'll bring only VB. Able to get this velocity of boat with respect to ground should be directed along AB. Then only the boat can move along the path AB. How to manage this? Throughout the problem, we'll use this convention, these symbols. For our convenience, we have brought it. Okay, now the same thing, just like how is the velocity of boat with respect to river? It was like this. Velocity of a river in this direction, and this was making beta. The river current was making an angle alpha with the path. Then what is the basic condition? The resultant velocity of the boat should be along path AB. So then what should be the component of velocities of boat with respect to river and the river perpendicular to the path AB? should be equal. So what should be the VB I should write? VB should be equal to VRB cos beta. I'm slightly deviating from the topics what we earlier we brought it here. This is along the path. Perpendicular to AB, the resultant velocity should be 0. So for that, so it will be VBR sine beta equal to VR sine alpha. Alpha we know, VBR we know, VR we know it. The beta is unknown thing, we can calculate from this. VBR, how much VBR? Where it is, check. What velocity? Okay, this is unknown thing, no? With what velocity u? This is unknown thing. Okay, what is VR? VR is 1.9. Alpha is 60. So let me substitute here. VBR, this is a u, this is unknown thing. Beta is what? AB is given, B is given, alpha is given. What angle? Beta is unknown, VBR is unknown. Okay, let's keep all these unknown things. VR is 1.9. Okay, I think again I have to get back all symbols, no problem here. B sine alpha 60 degrees. U sine beta, I know it. So if you know U sine beta, I wanted to continue same symbol, but some of you will get confused. So through symbols, I'm getting into a problem. VR is V, cos alpha, cos 60 will be 1/2. Keep it here. So now cos beta you can replace in terms of sin beta. So let's get into the time taken to move from A to B. That should be equal to AB by VB. What is VB? U cos beta plus V/2. U sin beta we know it. U cos beta is needed. So that I'll substitute here. And now similarly, time taken to move from B to A for path BA. I think A has to start because this alpha will not change. This is telling it will remain same. The velocity of river is here. The angle alpha will be same. In the return journey, so the resultant velocity, how it should be directed? It should be directed along the velocity of the boat, should be directed in this direction. VB dash will write it. It cannot be some other speed. So along BA, I think we can push it up. Along BA we'll see it. What is the equation? VB should be equal to U cos beta minus VR cos alpha. Let me write our directly. I write it. I can save time. Okay, this is the thing. Now after getting this perpendicular to BA, U sin beta V sin alpha. So what is the time taken to move from B to A? Should be equal to VB dash, this VB dash, this is AB by VB dash. What is VB dash? You can write it as time taken to move from A to B is equal to U cos beta V sin alpha. The total time is given for this. What is the total time? TAB plus TBA. TAB is AB by U cos beta plus V by 2. This we can simplify. V cos alpha, or V by 2 is, no? Plus BA by so we know T, we know AB, beta and U are unknown thing. I think we can solve it. Anybody? Cos 60, alpha is 60, no? Cos 60 will be 1 by 2. Yeah. Somebody should give me the value, final answer. Eight meters is what I have as speed. U is 8 meters. Check it. The beta is, you have to verify. I don't have answer. Approximately 12 degrees. I do remember. Now you have to ask me questions. So you have totally doing this problem in different way. Earlier you said that in velocity of swimmer with respect to river, use that formula. I am still sticking on to the same thing. Instead of along x, along y, now we are describing the problem along the path. Getting? Earlier the problems what we discussed is it was along the river current, perpendicular to river current. That was the method I brought. Now along the path we are resolving the velocities. Hope I able to understand. So this will be much easier. If you want, you can describe along x, along y. Lot of mass will be encountered. That's why this will be safer method. Sir, how come you can say this will be the? I think again the go for vector velocity of swimmer with respect to river, velocity of river. This should be the velocity of swimmer with respect to ground. The vector diagram I think is correct, because what is u? What is u here? U is velocity of swimmer with respect to river. Velocity of river, so that the resultant velocity of the swimmer with respect to ground should be along path AB. Don't know this. How to calculate this? We are using this vector. So I'll resolve the velocity of river and the velocity of boat with respect to river and velocity of river along this direction, and also perpendicular. If the perpendicular components are equal, then the resultant velocity can be along AB. No, there's a basic condition here.